Let's embark on a journey to build a command line interface, or CLI, calculator using the C programming language. The primary aim is to construct a basic calculator leveraging functions, which will perform simple arithmetic operations. The calculator will support basic operations such as addition, subtraction, multiplication, and division. We will adopt a modular design approach, creating individual functions for each operation. A user-friendly command line menu system will be implemented to interact with the calculator. Before diving into the code, let's establish the project's requirements and structure. Our calculator needs a command line interface, allowing users to interact via text commands. It must support the fundamental arithmetic operations: addition, subtraction, multiplication, and division. The code should be modular, with distinct functions dedicated to each operation. Input validation is essential to handle incorrect entries gracefully. Clear instructions should guide users on how to use the calculator. Finally, robust error handling is crucial, especially for preventing division by zero errors. Now let's define the project structure. The main function serves as the program's control center, orchestrating the calculator's operations. Addition, subtraction, and other functions will perform the respective mathematical operations. Now let's implement the core arithmetic functions that will power our calculator. The addition function takes two floating point numbers, a and b, as input and returns their sum. The subtraction function also takes two floating point numbers, a and b, as input, but returns the result of a minus b. Similarly, the multiplication function takes two floating point numbers, a and b, and returns their product. The division function takes two floating point numbers, a and b, as input, and returns the result of a divided by b. Now let's dive into the implementation of the main function, the heart of our C calculator program. First, we include the standard input-output header file, stio.h, which provides essential functions for input and output operations. Inside the main function, we declare an integer variable name choice to store the user's menu selection. We also declare two float variables, number1 and number2, to hold the input numbers, and a float variable named result to store the calculation result. The program starts by displaying a user-friendly menu of available operations: addition, subtraction, multiplication, and division. The program prompts the user to enter their choice, which is then read using the scamp function and stored in the choice variable. Now let's delve into how our calculator processes user input to perform the desired calculations. First, the program prompts the user to enter two numbers. These numbers are read using the scamp function and stored in the number1 and number2 variables. Next, a switch statement is used to efficiently route the calculation to the appropriate function based on the user's menu selection. For case 1, the addition function is called with number1 and number2 as arguments. The result is stored in the result variable, and the output is formatted to display the numbers along with their sum. For case 2, the subtraction function is called with number1 and number2. The result is stored in the result variable, and the output is formatted to display the numbers along with their difference. Now let's focus on adding error handling and input validation to our calculator. In case 4, which represents division, the code checks if number2 is equal to 0. If it is, a message is printed indicating that division by 0 is not allowed. Otherwise, the divide function is called with number1 and number2. The result is stored in the result variable, and the output is formatted to display the numbers along with their quotient. The default case handles invalid menu selections, guiding users back to the correct options. It prints a message informing the user that their choice is invalid, and prompts them to select a valid option from 1 to 4. Let's explore the complete program structure and how we can add a loop to allow for continuous calculations. First, we declare an integer variable name choice to store the user's menu selection. We also declare two float variables, number1 and number2, to hold the input numbers, and a float variable named result to store the calculation result. A character variable named again is initialized to y to control the program loop. The program is wrapped in a while loop that continues as long as the again variable is equal to y or y. The program prompts the user whether they want to perform another calculation. The user's response is read using the scamp function and stored in the again variable. After the loop finishes, a thank you message is displayed. Now let's explore possible enhancements. We can add more operations such as power, square root, and modulus. Implement memory functions to store and recall results. Add support for complex calculations with multiple operations. Save calculation history to a file. Support for different number systems like binary and hex. Implement unit testing for each function. Let's recap the key concepts that we've learned throughout this project. We've explored the idea of breaking down calculator operations into separate functions for better code organization and reusability. We've learned how to collect and validate user input for both menu selection and numerical values, ensuring a smooth user experience. We've seen how to implement checks for edge cases like division by zero and invalid menu selections, enhancing the program's robustness. We've gained insights into using loops and conditionals to create an interactive user experience with multiple calculation options. Try extending the calculator with additional operations, improve the user interface, or implement file input-output to save calculation history. Consider adding unit tests to verify each function works correctly under various conditions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.